Okay, so radians. Now, this is a bit of a confusing definition. I'll explain it once, but then afterwards there's an easy explanation to it. So, 1 radian is when you have a unit circle, you have the angle subtended by 1 unit. So what that means is the length. So if you think about it, you have the circumference being c equals to 2 pi r, right? The distance is on this circle is always going to be worth 1. If you manage to get that same length of it being 1, like so, then you have an angle of 1 radian in here. I'm sure that makes absolutely no sense to you, so I'm going to give you a simple definition. The simple definition of radians is we're measuring everything in terms of pi instead of using 180 degrees. What that means is 1 pi, C stands for radians, is equivalent to 180 degrees. Now, you might ask why you want to record everything in radians. Well, everything's in terms of pi, so it's a lot easier to work out for the angle stuff. So, to convert to from radians to degrees, you multiply by 180 divided by pi. It's on the right here. To convert degrees to radians, you multiply it by pi divided by 180. Best way to remember it, whichever one you want to get rid of, see how that's radians here, and you want to get rid of radians, you divide it by the pi. Same thing with the degrees. You have degrees there, you want to get rid of the degrees, so you divide it by 180. Fairly straightforward. Alright, so A, convert 30 degrees to radian measures. 30 degrees. We're getting rid of degrees, so what do I put on the bottom? 180. It says here, convert degrees to radians, multiply by 1 pi over 180. And I told you to check the bottom. If you want degrees, you get rid of degrees. So you divide it. Comes up by pi, so that becomes pi over 6, because 30 goes into 180 6 times. By the way, remember that 30 degrees is an exact value. You'll need to be able to convert that to radians and pretty much have it memorized. That'll be one of the activities you'll be doing in your book, okay? B, convert 4 pi over 3 to degrees. What do I put on the bottom of this fraction? What are we getting rid of, pi or 180? Pi. If you don't like the way I've explained it in terms of which one you're getting rid of, maybe think of it in a positive sense. If you're trying to change it to degrees, make the top degrees. If you're trying to change it to radians, make the top a pi. Yes? That's the other way of remembering it. Anyway, so the pi's cancel. 3 goes into 180 60 times. So then multiply the 2 and you get 240 degrees. Now, this will be switched in between for you. You might notice on this question there's a C. On this question there isn't. You switch in between whether or not you write the radian sign. So that C stands for radians. So in other words, 1C equals to 1 radians. If you don't have a pi written there, then you will write the C. If you do have the pi written there, quite often we just leave it out. Does that make sense? That's why I'm saying radians is in terms of pi generally. Any questions? So now notice this one doesn't have a pi. If it doesn't have a degree sign, you have to presume that it's in radians. So pi over 4. How do you convert that to degrees? What do I put on the top? The degrees part or the pi part? 180. Yes, 180. That gives you 45 degrees. Now, here's a test. What's sine of pi on 4, aka sine of 45 degrees? Two or three? Two. Okay? Good. Some of you remember it. Alright, last little bit. You might have seen this formula before. This formula is in radians. So there should be a C on the top. Don't forget to convert it to radians. The length of the arc, if you're not sure what it is, if you're planning on doing further, you'll see this anyway. The length of the arc is that section there. And there's theta. Okay? You might have seen it in general, I'm not sure, but you will definitely see this one in further. If you need to convert it to radians, don't forget to convert it. So, an angle subtended and an angle, an arc subtended and an angle of 56 degrees with a center of radius of a circle of radius 10 centimeters. Where's the full stop? Oh, I cut it out. Calculate the length of the arc corrected to 2 decimal places. So, it says the length is equal to r times theta in radians. What's r? What's our radius? 10. Now we need to convert this to radians. So we have 56 degrees. How do we convert it to radians again? Very good. Then we put all that in the calculator and we get our answer. Does 18 go to 56? No, it doesn't. Just really quickly showing you how to do this. Yeah. If you have something in radians, see how that's in radians, and you have something in degrees that you want to put in, just type in your angle. Let's say 45. There's a degree sign. When you press execute, it converts it because it's already in radians. If you have it in, if you want something in degrees and you have it in radians, let's say you have that, put that in there, press the R sign, and there you go. Simple enough.